Hello everyone. Today we're looking at the problem find the lexicographically largest string from the box 1, which was question 2 in weekly contest 430. So before we start, I just want to kind of rant a bit about the state of Leetcode contests recently. This, in my opinion, is one of the most poorly worded problems I have seen in a very long time. You'll see the acceptance rate is pretty low for this problem, around 20% right now, and even lower in the actual contest. And not because it's a hard problem, it's actually very simple, but either the question was written to be intentionally misleading, or the quality assurance and writing of these contest questions has really gone down in quality, and no one is checking. So, yeah, and in terms of difficulty as well, the contests are getting so much harder. I think the third problem in this contest was below a 3% acceptance rate. So they're really just getting extremely difficult, basically Codeforces level problems at this point. People have been very vocal about their complaints, about the cheating, about the quality of the questions, about the difficulty, but Leetcode really doesn't seem to care very much and continues doing the same thing. So I don't know what we can really do about it, but I think that as long as we stay vocal and really voice our concerns, hopefully we will be heard. And I think a lot of people feel similarly to how I feel, but I'm really disappointed with how these contests have been going recently. Anyway, the question reads that we are given a string word and an integer num friends. So Alice is organizing a game for her num friends, and there are multiple rounds in the game, where in each round, and before I go into the rounds, I will say that this is a lie. There are not rounds in the game. I don't know why they added this, but there is no concept of rounds here, so don't even worry about this. It is irrelevant. But basically what we want to do is we want to split the word into num friends non-empty strings, such that no previous round has had the same exact split. So again, this part of the sentence is irrelevant. We're not keeping track of previous rounds because there are no rounds, so just leave this entire thing out, basically. Then we put all the words into a box, and what we want to do is find the lexicographically largest string from the box after all the rounds are finished. And just forget this round because there are no rounds here. So the example is the word DBCA with num friends equals 2. Our output would be DBC. And this is because we could split the string in all these possible ways. So we can have D and then BCA, we could have DB and then CA, and then we could have DBC and A. And from all these splits, the largest substring we can get is DBC, so that is our answer. So I want to talk a little bit about lexicographical sorting and how it works, just as a refresher. So the most basic case is that we want to compare two strings, character by character, and in the first time we see that the characters differ, whichever is the largest will be the lexicographically larger string. So the most basic example is the second one right here, where we compare character by character. We see the first character is N and A. In this case, the N is larger than A, so this string is lexicographically larger than this one. Another case here is where we get to the end of one of the strings, but up until that point, all the comparisons have been equal. So you'll see we compare N and N, we compare N and N, and then we get to the end. So this still has letters here. So this one will be lexicographically larger than this string here, even though the comparisons up to this point have been the same. But the larger string is not always lexicographically larger than the shorter string. And we see that here because we go character by character, we do A and N, and we see that N here is larger. So this is immediately the lexicographically larger string, even though A and N is larger. Let's think about how we could split this string up. So we'll see that we have num friends equals 2, which means we have to split it up into two substrings. So let's think about that. Well, we could split it here, right? So then we have one substring here of just D, and then we have this CBA, which is a substring of length 3, and this is two substrings. We could also split here after the C, and then we have two substrings of length 2. Then finally, which would be our answer, we could split it after this B, so we get two substrings, one of length 3, one of length 1, and then this would be the largest we can make and would be our answer. So let's think about if our num friends was 3. What would that look like? Well, again, we could start and we could split here, And then, so let's say we split here as well. So now we have 2 substrings of length 1 and 1 substring of length 2. We also could do our second split after this B. So again, we have 2 substrings of length 1, 2 substrings of length 1 and 1 of length 2. Another option would be to split after the C. Then we'd have to split after this B to make 3 substrings. So again, have 2 of length 1 and 1 of length 2. So why am I showing you this? Well, you could see with the num friends of 3, we're always going to have 1 substring of length 2, right? And why is that? Well, you can see we could take that number, the length of the string, which is 4, we can subtract that number of friends from it, which is 3, and then add 1, and that gives us 2, right? And 2 basically means that we could have 1 substring of at maximum length 2, while all of our other substrings will be single characters, right? So here we'll see that we have this 2, which correlates to this 2 here, and then all our other characters are going to be of length 1. So this is the largest substring size that we can make given this number of friends. If we did it for 2, right, we can see we have 4 minus 2 plus 1 equals 3. And you'll see for the other example, where we had num friends equals 2, our longest substring was DCB, right, which is a substring of length 3. And that's the longest substring we can make for a size of num friends equals 2. So we can use this formula, the length of our word minus num friends plus 1 equals the longest substring we can make. And how do we actually use this information? Well, we know that the longest substring we can make is going to be of this size. So at this point, what we can really do is just kind of brute force it, and we can try every single substring that's up to that length, right? So we could try D, we could try C, we could try B, but then if we're on num friends 2, we can't go any farther because we know that 3 is the longest we can make, so we'd have to go to C. Then we could try C, we could try CB, we could try CBA, then we move on. So really what we're doing is we just need to find this longest length that we can make and then try all the substrings that are up to that length and record the maximum one. So this is not a hard thing to do, but again, this very simple problem was hidden in a very, very misleading description. So very understandable why people could not figure this out, but very simple problem under the hood. Another edge case we have to consider is where our number of friends equals 1. And what exactly does this mean? Well, we know we have to split it into num friend substrings, right? So how do we take this and split it into one substring? Well, actually, we can't do anything, right? To make this one substring, it's just the string itself. So if we ever have num friends equals 1, we're just going to take this string and just return it because there's nothing we can do. We can't split it any further, so we just have to return whatever we were given. So what is the time complexity of this algorithm? It's going to be O of n squared. This is because for each index, we basically have to check all the substrings starting from that index up to whatever value we compute, right? And this value could potentially be the same size of the string. So really, we're checking every substring potentially that we're given in this word. So it's going to be an O of n squared algorithm. Let's hop over to the code and see exactly how this works. So the code for this question is actually very simple. So first, we handle our edge case where num friends equals 1. In this case, we just return our word. Then we're going to have our max substring, and this just records our answer, whatever the maximum substring that we've seen so far is. Then we calculate our substring size, and this is the maximum substring size that we can have. And this is equal to the length of our word minus the number of friends plus 1. Then for each index, we're going to find the maximum substring from that point. So that will either be whatever we found previously, or starting from that index up to that substring size plus I. Then at the end, we're just going to return our maximum substring. So let's submit and make sure that it works. And it does work. So I hope this was helpful. Again, this is not a difficult problem, but the acceptance rate is so low just because of how bad the description really is. So I think we need to keep being vocal about the dissatisfaction with these contests and just how poor the questions and difficulty that we're given are. But hopefully this is helpful and it made sense. If you liked the video, please like and subscribe. It really helps out. And thank you for watching.